In this video, we want to take a look at some commands we can use when troubleshooting named EIGRP. That's a newer approach to configuring EIGRP. The same underlying issues are essentially the same for named EIGRP as they were for EIGRP for IP version 4 and EIGRP for IP version 6, the issues we talked about in the last two videos. However, we have some additional verification commands that I want to share with you in this video. First, let's review some of the basics of named EIGRP. And let's understand why we might want to use it in the first place. Well, think about it. With IP version 4, it could be fairly easy to set up an EIGRP configuration. We could say router EIGRP, give an autonomous system number, and then say network 0.0.0.0, and suddenly all of our interfaces that are administratively up, they're all participating now in this EIGRP process. That was easy. However, things start to get more complicated when we're adding support for IP version 6. We've got to give some commands under interface configuration mode. Maybe we need to go into EIGRP for IP version 4 configuration mode. If we want to tweak any parameters for EIGRP for IP version 6, we've got to go into that configuration mode. We've got all these different configuration modes we're bouncing back and forth between, and that can get a bit complex. The great news is, named EIGRP lets us consolidate all of this under one configuration mode. With named EIGRP, we take the functions that we would normally have to configure under interface configuration mode, EIGRP for IP version 4 configuration mode, EIGRP for IP version 6 configuration mode, and we consolidate them together in what's called an EIGRP virtual instance. This EIGRP virtual instance is made up of one configuration mode. And under this one hierarchical configuration mode, we can do everything we need to do instead of going into lots of different configuration modes. Under this virtual instance, we can define an EIGRP address family. We might create an address family for IP version 4. We can create another address family for IP version 6. And it's under address family configuration mode where we're going to set up the more general EIGRP parameters like our router ID. We can say whether or not a router is an EIGRP stub router. Something else we can do from address family configuration mode is enter address family interface configuration mode. And as just a couple of examples of things we can do here, we could set up an interface as being a passive interface. We could set up our EIGRP timers here as well. There's also an address family topology configuration mode. Here we give commands that have a direct impact on a router's EIGRP topology table. It's here where we could set up things like the variance option, where we could load balance across paths that have unequal metrics. For example, let's say that I've got two different ways to get to a destination network. One way has a metric of 1 million. Another way has a metric of 1.5 million. Well, normally I'm just going to go with the best route. I'm going to go with the lowest feasible distance. However, if I set my variance to 2, let's say, suddenly I can use that other route. Here's the way the calculation's done. We take the variance, which is an integer, and we said it's 2 in this example. I could say 2 times the feasible distance. We said that was 1 million, so 2 times 1 million is 2 million. By doing that, I've now set a range of acceptable values. I'm saying that if the metric is anywhere in the range of 1 million through 2 million, we can load balance across it. And we said that that alternate path had a metric of 1.5 million. Great, now we can use that by setting the variance. And something else we can configure under address family topology configuration mode is redistribution. Maybe we've got a couple of routing protocols running on a router, and we want those routing protocols to exchange route information. And now that we've reviewed some of the theory of named EIGRP, let's take a look at a live topology. Here in this topology on screen, I've got all of my routers configured with named EIGRP, and when it comes to troubleshooting, the same basic set of issues that we talked about in the last two videos, dealing with neighborships and dealing with routing, those same underlying causes still apply here as well, but I wanted to do a separate video on named EIGRP to show you some new show commands that we can use with this brand new type of configuration. First, let's take a look at our named EIGRP configuration. Let's do a show run, pipe to section, router, EIGRP. And here you see we're defining this EIGRP virtual instance, and I've got a couple of address families, one for IP version 4, one for IP version 6, and I've set things up like a variance of 2 for IP version 4. And I've given a network statement of 0.0.0.0 to make all of my up interfaces participate in the IP version 4 EIGRP writing process. There's really not much to configure for IP version 6. You just give this one command, and suddenly your interfaces that are up and have an IP version 6 address, they're participating in this process. But I wanted to show you some new commands. First, remember the command show IP protocols that we could use with IP version 4 and show IPv6 protocols we could use with IP version 6? Well, there's a similar command we have here. It's show EIGRP protocols. And notice the output from this one command gives us information about IP version 4 and the IP version 6 process. And we've got information like K values. We saw in a prior video that those have to match between our neighbors. We see that I've got a variance of 2 set here for IP version 4. Something that's missing though, specifically for IP version 6, when I did a show IPv6 protocols, I got this really useful information. I got a list of interfaces that were participating in EIGRP for IP version 6. We don't get that here in the output of show EIGRP protocols, and for that reason, many people prefer to go with the older commands. However, there is a way for me to see what interfaces are participating in this IPv6 routing process. I could say show EIGRP address family IPv6 interfaces. And I can see what interfaces are participating in the IP version 4 process as well. And I can get additional information by adding the detail keyword to the end of this command. This is going to show me things like hold time and the hello time. By the way, the timers do not necessarily have to match between EIGRP speaking neighbors. With OSPF, that's something that does have to match between our neighbors. Timers have to match. And while it's a good practice for timers to match with EIGRP, and if they don't match, you might have an instance where you have some flapping of your neighborship. It goes down, it comes back up. So it's usually a good practice to do it, but you can form a neighborship with different timers with EIGRP, something to keep in mind. We also see that split horizon is enabled. Do you remember what split horizon does? Split horizon says, if I learn a route coming into an interface, I'm not going to advertise that very same route out of that interface. I mean, why would I? If somebody tells me their resume, why would I tell their resume back to them? That doesn't make sense. However, if we're in a point-to-multipoint network, maybe like a frame relay network, where we've got a hub and spoke topology, it's possible that we might need to turn this off. So a route advertisement coming in from one of our spoke routers gets advertised back out of our same interface to go to another spoke router. And just like we can look at the interface table that EIGRP maintains, we can look at the neighbor table and we can look at the topology table. Let's say show EIGRP address family IPv4 neighbors, and we can see what IP version 4 neighbors we have. We can do the same thing with IP version 6, and we can also take a look at our topology table. First, for IP version 6, those are the networks known to EIGRP, and we can do the same thing for IP version 4. Well, that's a look at a few new commands that we can use to get information from our routers that are configured for named EIGRP. But please keep in mind, the older commands that we saw in the prior 2 videos, they're going to work too if we prefer to use those.